Why don't we fly the long, bitterly cold journey over the North Pole? You might think that it's a huge, pointless detour, but in reality, that's far from true. In fact, it saves time. The issue is actually the area's havoc-wreaking magnetic field. It messes with navigation systems and even our own beloved technology. But what if we did fly over the North Pole? If everything went wrong, could we be rescued? Let's find out. First off the bat, let's talk about the North Pole's chaotic magnetic field. When planes reach their cruising altitude, autopilot usually takes control. But how does it know which way to go? Well, thanks to high-tech GPS satellites as well as inbuilt magnetic compasses which compare the plane's current location to the location of true north at the North Pole. Here's the problem though, the magnetic compasses can't handle the intense magnetic field that the North Pole dishes up, especially older planes which rely on compass equipment instead of GPS. Magnetic anomalies aside, if the plane is smack bang over the North Pole, autopilot will be scratching its mechanical head, trying to figure out a route when literally everything is considered to be south. Okay, but we live in 2019, so can't we just adjust our systems to fix it? Well, no, because the solution is always changing. Per day, the magnetic field moves in loops of up to 50 miles. And its central location moves every year by around 25 miles, not to mention the constant variation in strength as well. One day it might not affect the plane systems whatsoever, but the next, south could appear as north, west could be east, and you could find landing on Mars instead of Madrid. When the pilot can't clearly define which way true north lies, that's when everything starts to hit the fan. Throw in a lack of visibility due to snow, ice, and a 6-month nightfall, and well, you're probably screwed. Pilots could theoretically rename their runways to deal with the problem, since airport runways are usually named based on their relationship with true north. But this is just a band-aid solution. Hold on, if the magnetic field is affecting the plane's technology, does that mean it can mess with our beloved gadgets as well? The short answer is no. Thankfully, your precious iPhone and laptop will live to fight another day. Engineers routinely test basic electronics and magnetic fields up to 2 million microteslas. In the Arctic, we're only slapped with about 65 microteslas of energy. By comparison, a powerful fridge magnet has about 1,000. So 65 might not seem like a lot, but considering that Earth's magnetic field at the equator is only around 25, it's still almost 3 times more powerful than what we're used to. Granted, your phone's GPS might play up a little, but you should have it in airplane mode anyway, right? Even then, once you're out of the magnetic field, everything will be back to good old normal. What about your credit cards? Don't worry, your money's not going anywhere. Yet. That black strip on your credit card is actually magnetic. And what happens when 2 magnets interact? If you think back to high school science class, they either attract or repel each other, which for credit cards can cause something called demagnetization. But at the end of the day, the force isn't strong enough in this one. You'd usually need around 30,000 microteslas to mess up your Amex, and since the North Pole's field is only around 65, you should be fine. Let's say hypothetically that flights could routinely fly over Santa's neighborhood. How would it affect our flight paths? If you think it means you'd be late to dinner in Dubai, sorry folks, try again. On a 2D map, the quickest way from Los Angeles to Doha on Qatar, Flight 739 is a straight line. Duh. That would cut through northern Africa and over the Pacific Ocean. But sorry flat earthers, since the Earth is round, that 2D map becomes irrelevant. Due to the Earth's natural spherical shape, flights such as this one tend to avoid the Pacific Ocean altogether and fly up to the North Pole instead. Why? Because when we take that 2D map and make it 3D, you'll see that overall, the distance is indeed shorter. Along with the curve, it measures out to just under 8,300 miles, while the straight line chalks up a whopping 10,200. So that being said, if flights could fly over the North Pole, to save time and money on fuel, they would. Although, according to enforced regulations, 60 nautical miles from the North Pole is the closest planes are actually allowed to fly. So while Qatar 739 does get close, it's forced to still keep its distance. Speaking of fuel, as you'd expect, it's pretty darn cold up at the North Pole. Like mittens and a knitted sweater just ain't gonna cut it. With temperatures well below freezing, airlines must also be aware of their onboard fuel. In the USA, Jet A is the most common type of aviation fuel, and that freezes at -40 degrees Fahrenheit and -40 Celsius. The colder the air around the fuel, the faster it'll freeze, and in the sky, the higher the altitude, the colder the temperature. For that reason, if you're flying over the Arctic, pilots need to drop the altitude, which adds extra time to the journey, although still far less time than tracking all the way across the Pacific. Even if airlines standardized technology to overcome all the issues we've been talking about, pilots wouldn't even know what to do with it. As it stands, the majority of crews aren't actually trained to handle the unique North Pole environment if things were to go wrong. What if an engine malfunctioned and they had to make an emergency landing? Think about it. They're so far from civilization with almost zero resources in the area, so there's no way a rescue squad would arrive anytime soon. And just a few minutes out in the open air could bring on hypothermia. Don't forget that it's nothing but darkness from October till March, so pilots wouldn't be able to see if what they're attempting to crash land on is ice or a whale's back. Like Qatar 739, some planes actually do make the trip over the Arctic. But they're specially built and are forced to follow strict instructions, like carrying extra gear, including cold weather suits for the crew, highly specialized communication equipment, and recovery plans for stranded passengers. With all these factors coming together, it's no wonder that airlines avoid the North Pole like the plague. The North Pole isn't the only place we aren't allowed to fly over either. The South Pole for similar reasons, Tibet due to the jagged mountain ranges, Area 51, and believe it or not, Walt Disney World aren't allowed to feature in any flight path.
Flatten the curve, flatten the curve, flatten the curve.
That's all for why planes don't fly over the North Pole. If it was up to you, would you fly over it? Let us know in the comments.